So put a heading on worksheet 5-7 and let's draw a picture to illustrate polynomials on a graph, and then we'll go through our 4 bullet points. Let's see, let's create x-axis. So I see that this curve crosses the x-axis 1, 2, 3, 4 times. So this is most likely a quartic function, meaning it has degree 4. Let's call this root, where it crosses the x-axis, let's call this one C. And I just want to go over some vocabulary with you today. Created some bullets here. Does everybody agree that C is a 0 of the function? You're comfortable with that word? Mm-hmm. The reason it's a 0 is because that's what y equals. So if I wrote the ordered pair of this point, you would say C, comma 0. Agree? Mm-hmm. And then I also put that right here. And it is an x-intercept of the graph. Other words that we can use for C, ladies and gentlemen, C is a root, or I could say C is a solution because that's what x is equal to when y equals 0. Another name for f of x equals 0 is just y equals 0. Are you good with that? Okay, last of all, look at this third bullet. If I tell you x equals c, you could tell me that x minus c equals 0. That's what we've been doing these last few days. So we would say x minus c is a factor of the polynomial f of x. So there's a summary of all the vocabulary words that I want you to be comfortable with polynomials. Now, the fundamental theorem of algebra and its corollary simply tell us that if you have a polynomial of degree n, then you should be able to have exactly n roots. So this is a polynomial with a 4th degree because we can count 1, 2, 3, 4 roots. We're going to save our rule of signs for tomorrow when our others get back. So if you would move down to example 1 with me, and this is just more review. I do not think you'll have any trouble with this. Example 1 asks us to solve the equation and then state the number and type of roots. First of all, what degree is this equation?
3.
So how many roots should I be able to find?
3.
Good. That's the fundamental theorem of algebra. That's a fundamental fact from algebra. If your degree is 3, then we should find a total of 3 roots. Let's begin to break down this polynomial by factoring. I see a GCF of 3x. So now set each factor equal to 0. actually, can we get rid of this 3 right here by dividing both sides by 3? And it just goes away, doesn't it?
Wouldn't it be 2x squared, not 2x cubed? Since
Right
we took
here?
out an x.
How's that look? Does that look better? Fix that on your paper. Thank you. So let's divide both sides by 3. And we end up with x equal to 0. And there's our first root. Now let's take the second factor here, 2x squared plus 1 equal to 0. So 2x squared equals negative 1. Divide by 2. Cancel out the square by taking the square root of everything, numerator and denominator. And then class, will you help me rationalize this denominator? I do not want a radical sign in the denominator. That would give me an irrational number. So help me rationalize the denominator. Let's multiply top and bottom by square root of 2. You learned that in Algebra 1. What is our Algebra 2 symbol for square root of negative 1?
I.
So plus minus I times the square root of 2, the whole thing over square root of 4, which is, look at that beautiful rational number. So ladies and gentlemen, did you and I just find 3 roots because of that plus minus?
Yes.
Now let's describe them. I have 1 real root, and I have 2 imaginary roots. Let me squeeze in another example. What if I had something simple like this is a perfect square trinomial pattern. We love perfect square trinomials, and I've been practicing and practicing this pattern with you so that you would memorize it. How does a perfect square trinomial factor every time? Every time. Does it factor into a binomial squared?
Yes.
So, ladies and gentlemen, this is a second degree polynomial. Quadratics are degree 2. And you must have 2 roots. In some cases, however, when you set this x plus 3 equal to 0, you get x equals negative 3. But it is considered a double root. So we get to count it as 2. So here we have 2 roots, but they're both the same number, minus 3. So quite often we just write it once. And in our heads, we know this is a double root. Okay, we'll save example 2 for tomorrow. Will you turn the page? For homework tonight, I need you to do this section just like example 1. So will you just do number 1, number 2, and number 3? And I'll give you some time to get to that in just a moment. Turn the page, go to page 3. And I want us to look at the complex conjugate theorem. Ladies and gentlemen, the complex conjugate theorem says imaginary roots will always come in pairs and they will be conjugates of each other. To find imaginary roots, ladies and gentlemen, you have to take the square root of both sides. And when you take the square root of both sides, you must put plus minus in front of your square root. Do y'all agree? So that causes all imaginary roots to come in pairs. One's plus and one's minus. So turn the page now. You do not have to do this page for homework, by the way. Go to the last page in your packet. And I want this section done for homework. So 1, 2, 3, 4 on the back page. Let's read the directions. Write a polynomial function of least degree. That just means simplified. With integral coefficients, so that means integers, no fractions. That have the given zeros. Okay, Algebra 2 students. If I tell you that your zeros are 4, -1, and 6, remember our discussion on the first page? That's telling me that x equals 4, x equals -1, and x equals 6. So I have 3 zeros. So I need to be able to create a third degree polynomial. Well, we can do this. Let's set each of these equal to 0 and create factors. So here I would have factor x minus 4, factor x plus 1, and factor x minus 6. Equal to 0 because y equals 0 when x equals these numbers. Does this turn out to be just a multiply problem?
Yes.
And ladies and gentlemen, since it's multiply, you can multiply in any order. So if you happen to see matching pairs, that's a pattern. I would multiply those together. If you happen to see conjugates, I would multiply those together first. Here we have 3 different numbers, so why don't we just multiply these first 2 together? Using FOIL. FOIL is basically just distributing first.